Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. And in this video we're going to look at the N-to-M line decoder. Now the N-to-M line decoder is sometimes called a min-term generator, and we're going to see why further in this video. So I think that's all I need to tell you at this point, so let's get started. So N-to-N line decoder. So this decoder takes N inputs and gives 2 to the N outputs. Only one output is active at a time. The output that is active is the min-term represented by the input binary number. Okay, we'll explain what that means exactly. So this is an N-to-M line decoder is something that generates every min-term possible for those inputs, and then only one of those outputs are active, and that's the min-term that's selected by the input at that moment. So let's do a 2 to 4 decoder, and so we're going to do X, Y, and then we'll go ahead and bar those as well. Okay, and so 2 to 4, actually I'll go a little bit lower. That means I'm going to have 4 AND gates. This is like sum of products form, right? And so each of these AND gates is going to be one min-term. This is going to be min-term 0, it's going to be min-term 1, min-term 2, min-term 3. So remember, min-term 0 is equal to X bar, Y bar, Z bar, right? So that's M0. And so, oops, just X bar, Y bar, because we only have 2. And so I'm going to take X bar and Y bar and put it into 0. And then min-term 1 is going to be X, Y bar. And so I'm going to take X and Y bar, and this will generate min-term 1. So this is min-term 0, this is min-term 1, right? And then min-term 2 is going to be oops, I'm sorry, I got this wrong. Min-term 1 is going to be X bar Y. Let's fix that. Ugh. Okay, just get rid of all that. Sorry about that. X bar, Y bar, 0, 1. And then we have to fix the, oops, there we go. Okay, let's start again. So we got X bar, Y bar for min-term 0, and then X bar, Y for min-term 1, and then min-term 2 is going to be X, Y bar, and min-term 3 is going to be X, Y. Okay, got that now. X, Y bar, and then X, and Y. Okay, so I'm doing 2 to 4 so we can see what's going on here as we generate each of these min-terms. Now remember, the definition of a min-term is that a min-term is generated for that input sequence, and all other min-terms are going to be 0 when that min-term is 1. So that means that only one of these outputs is selected at a time, like we said over here on the left, right? So only one is selected. And so this is it. This is what the decoder looks like. And so we can take one of these outputs here, and we can call this like D0, D1, D2, and D3, and they're just generating the midterms. Okay. Now, to bring this a little bit further, we can actually use this to build a Boolean expression. And so, when we write a Boolean expression, we can write it in terms of the midterms. And so I might say that, hey, we have a expression f, and that's equal to midterm 1 or midterm 3. Okay? And so since I already have the midterms generated by this decoder, it's really a simple process of just taking an OR gate and saying, hey, let's bring in midterm 1 and bring in midterm 3, and that generates F1. So this is a way we can use a decoder chip, if you had one, right, to actually implement a Boolean expression. And that's how you would do it at this point here. Okay. So that's really all I wanted to show you here for the N-to-M line decoder. Let's go and take a look at a simulation. Okay, and this one looks a little more complicated because it is a 3 to 8 N-to-M line decoder. Let's see if I can get this as big as we can here. Okay. Maybe I'll even be able to keep my picture-in-picture in there, at least a little bit. Okay, perfect, that looks great. Actually that looks better. So what we have here is 3 clocks that are set up to do a count. And so we have 1 hertz on the least significant, half a hertz on the next one, and 0.25 hertz on the most significant bit. And so these are all toggling at factors of 2 lesser frequency as we go to higher bit significance. Now, I've routed these inputs to a hex display so we can see what midterm it's selecting. So if this said 000, then it would be the 0th midterm. If it was 001, it would be the first midterm, and so on and so forth. And at the same time, I've put the decoder here, and we've connected the wires appropriately, and I won't take you through that. But we can even see in this pause position that it says midterm 1, and we are selecting midterm 1 as the only output that has a 1 right here. So let's go ahead and run this. And then you can see as we're going through, so midterm 6, and then 5, midterm 4, midterm 3, midterm 2 coming up, so on and so forth. And this makes sense that it's counting because I set it up to do a count. And so we can see that only 1 is active at a time, and it's representing the output line that is corresponding to the midterm number. So that's it. One thing you might notice is that it's counting down and not counting up. And I'm going to throw that question out to you. I had that thought when I first looked at this. I was like, why is it counting down and not counting up? And then I investigated a little bit and figured it out. I wonder what you think. Why is it counting down and not counting up? So go ahead and put a comment down and see if you guys can have a little discussion about that. All right, I'm Mike Stanzik, and this is Digital Electronics Classroom. And I hope you found value from this video, and as always, have a wonderful day.